So, in chemistry, we study matter. So, let's talk about how we find matter in the world. And the place that we'll start here is with states of matter. And matter is anything that occupies space and has mass. It's classified according to its state. And these are maybe things that you've heard of before, or that, at least at some level, you have kind of an intuitive understanding of the difference between a solid and a liquid and between a liquid and a gas. But as always, we'll define them from the perspective of a chemist. So, what we have in this picture shows what a solid might look like, and we define it as something that has a fixed shape and a fixed volume. A liquid will have a fixed volume, but the shape of it will change depending on the container that you put it in. A gas does not have a fixed volume or a fixed shape. So, in this same kind of container, a gas would expand to fill the entire container. We can also classify matter by its composition. So, this is a really good flow chart for figuring out what type of matter you have, what types of terms can you use to talk about it. That also helps you understand how it's made up. So, if your matter has constant properties and composition, so that's a yes, it's considered a pure substance. If it doesn't have constant properties and composition, it would be considered a mixture. After that, so if we're on the mixture side, so we can just go left to right here, it doesn't have constant properties and composition, but is it uniform throughout? If the answer is no, then it's a heterogeneous mixture. If the answer is yes, it's a homogeneous mixture. And don't worry, I have examples right after this that will help us understand what that means. For a pure substance, if you can simplify it chemically, so I guess that's a yes, then it's a compound. So it might be made up of other things. It might not be easy to simplify it chemically, but you could. And if you cannot simplify it chemically, then it is just the element. Some great examples. An example of an element is helium. So something that I've just read off the periodic table, which don't worry, we have videos about the periodic table that we're going to go through. It has a constant set of properties and composition, and you cannot simplify it chemically. A compound example would be something like carbon dioxide. It's a pure substance because it has constant properties and composition, but it has carbon and oxygen in it. So it'd be kind of difficult, but we could simplify it chemically. So it's a compound. A homogeneous mixture, something that's uniform throughout, would be something like sweet tea. If you look at properly prepared sweet tea, it's a translucent liquid. It has a constant color, but we know that there are different things in there. So there's water, there's sugar, there's all of the different compounds that are extracted when you make tea, but you cannot see those individual things and they don't separate on their own. A heterogeneous mixture would be something like vegetable soup or wet sand, right? You can see the individual pieces that were mixed together to make this mixture, and like you can just visibly discern them from a macroscopic level. So separating mixtures is something that is really important to us as chemists. We won't deal a lot with it in general chemistry, but when you take organic chemistry, it will become an even more important part of what you study in terms of chemical properties. So the method of separation depends on the type of mixture and its components. And we're going to go through this mostly so that you have definitions to associate with these words. I'm not really going to ask you problems about how to separate things based on these words. So decanting means to carefully pour off the liquid and leave the solid behind. So this is something that you could use to separate a heterogeneous mixture, right? So it's not uniform throughout. You maybe have solid pieces and you're going to try to pour the liquid off and keep the solid in. So I guess the same as when you strain a pot of pasta, right? You could try to carefully do it. I never successfully do this. I always dump half my pasta down the drain, but you could attempt to decant the water from the pot of pasta and leave the pasta behind. Filtration means to pour the entire mixture through a funnel with filter paper. This is also something you would do with a heterogeneous mixture, and something like a piece of filter paper or a pasta strainer would act as the filter. So you just dump everything in and rely on another piece of physical equipment to do the separation for you. Distillation separates homogeneous liquid mixtures by boiling point. So when you distill something, remember for a mixture that the properties are not uniform throughout. So if you mixed, let's just say water and rubbing alcohol. They're two different chemical compounds, but if you were to pour them both into the same container, you would not be able to tell them apart. It's not going to form a layer. They're just going to mix really well. But the chemical properties of the water and the chemical properties of the rubbing alcohol are still distinct and unique, which is why it's a mixture. So if I boiled that mixture and I had the right equipment, I could separate the two components from each other. We should also talk about chemical and physical properties and chemical and physical changes, because these are also ways that we talk about how we do things to elements and compounds, and it tells us what to expect as the result, or if we have, a reaction is really what we'll get to. But if we have something applied to a chemical, you can see the before and after, you have a description of the before and after, you will be able to describe if it is a physical property, a physical change, a chemical property, a chemical change. Now, the property versus change can sometimes be so interrelated that it's hard to tell if you're describing a property or a change. However, physical and chemical will always be very discernible. At its most basic level, if you're looking for the difference between a property and a change when you're given a sentence and you're asked to figure out what it is, if it's a change, that description will have some kind of action verb in the sentence, and you'll see some examples to help you figure this out. The property means that we're just describing something about that object. So a physical property is a property displayed by an atom or molecule that doesn't change its composition. So the boiling point of water is a property of water. So if you have water, it always boils at the same temperature. Color can also be a physical property. So the color of a wax would be the physical property of that wax. The change, so a physical change, is a change that alters the state or appearance, but the identity stays the same. So boiling water, so that is an action, as opposed to the boiling point, which is a description of a point at which that action would happen. Boiling water is a physical change because it is liquid water before and gaseous water after. The boiling point would be the physical property. A chemical property is a property displayed by an atom or molecule when undergoing a chemical change. So here we say things like flammability, where the change version of that would be burning, or we say reactivity with oxygen, and the change version of that would be reacting with oxygen. So, I guess we should say the chemical change definition. It's a change that alters the composition of matter. So the identity changes as it goes through this process.